All right, this is our first uh, meeting together to go over where loads of people are getting kind of clogged up in the Algebra 3 curriculum. And so we're going to have some time to work together, and students will be able to ask questions. We may have some joining us as we go. We're starting with complex numbers. So this is going to be like looking at 1.06 and the kinds of problems that you might find there. Now, complex numbers are really, they're about the number I. And just as a reminder, I is equal to the square root of -1. And so that's going to be the place where we're starting is up to this point, you've been told that when you have a square root of a negative number, that there's there's no answer. But now we're learning that there's these complex numbers. Complex numbers have real and imaginary parts, and we'll talk more about that as we go. So first, we're going to look at simplifying a situation like this. And so this is 5 times the square root of 49, and then we're adding to that the square root of -25. So right there, that's where we see complex numbers are going to be coming into this situation. The first thing I know is that I need to simplify this square root right here. Well, the square root of 49 is 7 because 7 times 7 is 49. So this is going to be 5 times 7 because it was 5 times square root 49. So we're just simplifying this square root of 49 as 7. Now, the next part that we're going to do, I'm going to be kind of trying to make this as clear as possible when I'm talking about the square root of -25 here. I'm going to break it down into a few steps. First, I'm going to, underneath the square root, we could do 25 times -1. So I just took that 20 -25 and I broke it apart into 25 times -1. And the reason why I did that is so that we can then break this square root apart into 2 separate square roots. Because we have multiplication here, and that's all there is just multiplication. We're allowed to do that. But first we have 5 times 7, and that's 35. And then we can break apart this single square root into 2 square roots. Square root 25 times the square root -1. And as I said at the beginning here, the square root -1, that's I. So now we're going to also have to deal with the square root 25. Because 5 times 5 is 25, the square root of 25 there is going to be 5. So I'm going to rewrite that. And I'm also going to rewrite this square root -1. So we have the 35 plus, and then square root 25. That is 5, as I said. So make sure that I got that from the square root 25. And then the square root -1, that is just I. So that's where that came from. And so that is our answer. 35 plus 5i. Now, here is the real part. It's a real number. And here is the imaginary part. It's got that I in it, the square root -1. So that's the imaginary part of the complex number. So that's our first problem right there. Any questions going over that one? All right. So I don't think that actually my audio is going to be picked up. Students won't be heard on the video that I'm recording. So you still respond normally, but I'll just repeat the question to make sure that the video is recorded. So here, it's the same kind of problem. And I'm not going to do every single step the way I did the last one. This is how I would normally do it. In the other one, I was making sure that every single step was explained. Here, I don't know if it's much of a shortcut or, shorter, but I can rewrite this as, well, the square root of 100, that's 10. And then we have that square root negative 1, which is I. So it's a perfectly fine step to go straight from square root negative 100 to 10I. I'm okay with that. It's a good step. And then we have a minus 2, and then the square root of 16 here. Well, that's going to be 4. So that's going to be 2 times 4. And so finally, that's going to be a 10I minus 8. And I'm actually going to ask that we rewrite this just because there's a standard way of writing complex numbers. We write the real part first, which is negative 8 plus 10I. So first comes the real part and then the imaginary part. And that's just a standard way that we write complex numbers. So questions there. Are you okay with going from this step to that one, or do you like the way I did over here to break it apart into these two separate pieces? Okay. So this one makes more sense. All right, great. So now we're not going to look at any more of those kind of converting square root negatives into i's. That's really what we're looking at there, just thinking about what a square root means. But now we already have I involved, and here's one complex number, and we're multiplying it by another complex number. So an interesting thing happens when we multiply two complex numbers. Now, it's very much like foiling, as if instead of I, we had X, firsts, outers, inners, lasts. It's the same thing, except instead of X, we have I. So multiplying our first terms together, so 2 times negative 5, that's going to be negative 10. Actually, I'm going to go down one more, negative 10. And then outers, so 2 times negative 4, negative 4i, excuse me, that's going to be negative 8i, and then inners, negative 3i times negative 5 is going to be a positive, because a negative times a negative is a positive 15i. And then we have our lasts, negative 3i times negative 4i. While a negative times a negative is a positive, 3 times 4 is 12, and I times I is I squared. And I think this is where the most interesting thing happens when we're thinking about these kinds of problems. So I'm going to combine my two terms right here in the middle. So the negative 8i and the positive 15i. And I will get to negative 10. Then that's going to be plus a 7i plus 12. And then this I squared is equal to negative 1. So I'm going to use purple here. No, I already used purple, so I'm using the pink. Sorry. So that's going to be I squared is negative 1, and I can talk a little bit about that to make sure it's clear why it equals negative 1. I think that's useful. So now this positive 12 times negative 1, that is going to be a negative 12. And now the last thing to do combine is the negative 10 and the negative 12, and that's going to be negative 22 plus 7i. Now, any questions on that problem before I'm going to talk a little bit more about this I squared and why it's negative 1. But any questions first? So when it is in this form, there's nothing else that we can do because it is just a complex number. There's a real part, there's an imaginary part, there's nothing else we can do to simplify it. All right. Anything else on that one though first? All right. So I want to talk a little bit about this I squared then. And let me see. All right, good. So I have some room down here at the bottom that I should be able to use. And we're going to just start with the fact that I is equal to square root negative 1. And that's just a definition. So we just decide, and mathematicians decided, listen, we're not going to use I as variables or unknown values anymore. Usually we use X, that's the most common, but never ever use I, because now I is equal to square root negative 1. Okay, that's good. We can deal with that. And then, though, the result of that is when we think about I squared, what we're saying is square root negative 1 squared. And it's important to remember that squaring and square rooting are inverses of each other. They undo each other. So if we have something like square root of 7, and then that whole thing is squared, then the result is 7. If we have square root 19, and that whole thing is squared, then it's 19. If we have square root 108 squared, then the result is 108. So whatever is underneath the square root, when it's squared, is the result of the problem. So in this one, the result, since we're squaring the square root, the result is just a negative 1. And so that's a really big thing right there, that I squared is equal to negative 1. So up here, I said I squared was equal to negative 1, and this is the explanation for why. Is that okay? Okay, good. So next we're going to talk about I cubed. And what we're going to need to remember is that we have these exponent rules. That I cubed, well, we could think of that as I times I times I, which we could think of as, well, this is I squared right there. So it's I squared times I. So usually I just talk about this step, but today I was thinking, hey, if we think about I cubed being this, then it's easier to see where this I squared is coming from. But then we still have times I. But we just said up here that I squared equals negative 1. So this equals negative 1I. But I don't need to say negative 1I. I can just say negative I, and that's the same thing. So I cubed equals negative I. All right. I to the 4th. I'm not going to. Oh, I'll do it. So it's going to be equal to I times I times I times I. And this is I squared times I squared. So I squared times I squared. Well, each of those is negative 1. So negative 1 times negative 1 is 1. So I to the 4th power equals positive 1. All right. So now I'm going to kind of move these over just a little bit so that they don't take up so much room going out to the right there. And then I'm going to start back up here with I to the 5th power. And the reason why I want to do that is because we can think of I to the fifth power as I to the fourth times I. So the same way I broke up I to the fourth down here. So this I to the fourth is just the same as that times the I. What was that? Okay, good. And so I to the fourth power is equal to 1. So this equals 1 times I. So I to the fifth power is equal to I. It's an unusual number, I. I to the sixth power is equal to I to the fourth times I squared. Well, I to the fourth is 1, and I squared is negative 1. So this is 1 times negative 1, and that's just negative 1. Alright, I to the seventh is equal to I to the fourth times I cubed, which is 1 times, well, I cubed is negative I. So 1 times negative I is negative I. I to the eighth is equal to I to the fourth times I to the fourth. Well, that's 1, because I to the fourth is 1 times 1 is 1. And notice the pattern. I, negative 1, negative I, 1. And it will continue like that forever. So I to the ninth is equal to I to the 10th is equal to negative 1, I to the 11th is equal to negative I, and I to the 12th is equal to 1. And it continues on like that. Any questions on that? Great, good. All right, so that's just an important thing about I, and you'll find that show up in some problems. In fact, it shows up when we are multiplying two complex numbers like this. So let's go back through another one of these. So first, negative 6 times 5 is negative 30. Outers, negative 6 times negative I is positive 6I. Inners, positive 2I times 5 is positive 10I. And last, positive 2I times negative I is negative 2I squared. All right, now I'm going to combine my I terms and get 16I. So I have the negative 30 plus 16I minus 2 times negative 1, because I squared is negative 1. Negative 30 plus 16I plus 2, because negative 2 times negative 1 is positive 2. And last, negative 30, negative 28. Negative 28, because we have negative 30 plus 2 plus 16I. Questions there? Okay. I was going to start on simplifying polynomial expressions next, but there's something else that I was thinking about that actually would be useful to discuss as well. And that is when we have something like this, we have 2 plus 3I and 2 minus 3I. These are called complex conjugates. They're complex numbers. That's what makes them complex conjugates. And the thing that makes them conjugates is that they have the same real part, and their imaginary parts are just different by a sign. One's positive, one's negative. The way that we often show complex conjugates is A plus or minus BI. So the A value is the real part. And then we have plus or minus, plus or minus. The B value in this case was 3, and then I. So complex conjugates are important. It turns out that whenever you're solving for like solving a quadratic equation, if your answers are complex, then they will always come in complex conjugate pairs. So if I tell you that 2 plus 3i is a complex solution to a quadratic equation, then you automatically know 2 minus 3i is also a solution to that equation, and vice versa. So that's an interesting thing about complex conjugates. And also, something interesting happens when we multiply complex conjugates. So let's look at an example of, let's just take these two, 2 plus 3i times the quantity 2 minus 3i. And I'm going to move through this pretty quickly. Tell me to slow down if you're like, nope, I don't see what you did there. Tell me to slow down. 2 times 2, that's 4. 2 times negative 3i is negative 6i. Positive 3i times 2 is positive 6i. And you may see what the interesting thing is that happened. Positive 3i times negative 3i is negative 9i squared. These I terms cancel. So we're just left with 4 minus 9 times negative 1 because I took that I squared and just rewrote it as negative 1. So we have 4 plus 9. So I'm going to have to move that down a little bit further, which is just 13. So notice that there is no longer an imaginary part when we multiply these two complex conjugates. That's always going to happen. The imaginary part is gone when we multiply complex conjugates. Would you like to see another example of that? No. Okay. All right. So that's where I'm going to stop when it comes to the complex numbers for now. Hopefully that helps you to understand complex numbers. And I'm actually going to stop the video here, and I'm going to, I think, start another video.